The four-step Redux lifecycle. The flow always follow these steps in order. First, action dispatch. An event in the UI, like a button click, triggers a call to store the dispatch action. The action is a plain JavaScript object describing what happened. So you're essentially triggering or like executing a function in the UI that will trigger the action or the plain JavaScript object. Second, reducer extension. The store passes the current state and the dispatch action to the reducer function. So that's the missing link. There's a store that passes the current state of the application and apply the dispatch action to that state for it to produce a new state. The reducer is a pure function that calculates a new state based on the old state and the action without modifying the original data. State update, and then after that, the store saves the new state tree returned by the reducer. So it doesn't just create new state, it also save it. So it has an entire memory itself. Later or moving forward, we will discuss how this itself has an entire memory that keeps it like an in-memory view or structure for the application. So the store saves the new state tree returned by the reducer. This state becomes the single source of truth for the entire application. So to refine this further, it will update the global state and then contact Supabase and then contact PostgreSQL to update the single source of truth. And basically, this is what RiverPod approximately do, but the difference is that RiverPod is kind of like a diffing algorithm where it doesn't create a new state, but it change small the small things that change on that previous state. So it doesn't need to like create an entirely new one. It can update the old one, but it can update it lazily or more efficiently than updating everything from scratch. UI render, the store notifies all subscribed UI components that the state has changed. Components pull the new data they need and re-render to reflect the update. Key components of the flow: state, a snapshot of the application data at a specific point in time. Actions, plain objects with a type field that serve as the only way to trigger a state change. So this is like your interface to trigger that state change on the store or to be able to contact the store to execute that reducer to create a new state. Again, reducer are functions that act as event listeners to handle actions and determine how the state should transition. So later we will see reducer similarities to RiverPod. It's related to providers. Store, the central object that holds the state, allow access via getState and handles update via dispatch action. Benefits of this pattern: predictability. Because data only moves in one direction, you can easily trace which action causes specific state change. Debugging, it enables time travel debugging, allowing developers to step backward and forward through every state change in the app's history. Maintainability, by separating state management logic reducers from the UI components, the code becomes more modular and easier to test. Consistency, it prevents syncing issues common in two-way data binding as there's only one source of truth.